In this lesson, we'll investigate the interaction between the working memory system and the long-term memory system. The idea is a long-term memory begins in working memory. So whatever it is we're currently experiencing, whether we're perceiving something or reading something or listening to a lecture or something, that whatever's in our working memory, that information has the potential to be written to the long-term memory system. This is how we can make a long-term memory. But it begins in working memory. Now, in past lessons, we've used the temporal cortex to be our sort of location for long-term memory. But again, in reality, scientists think that long-term memories can be stored in widely distributed areas across the cortex. But we're going to use the temporal cortex to be our location for long-term memory. So we have a situation like this, that the contents of working memory can be used to trigger the activation of long-term memories in our long-term memory system. So this would be the nature of the interaction then, that the working memory system has access to the long-term memory system. So let's give an example. Notice we have the visual cortex, so whatever we're seeing is going to be loaded up into working memory. What we're hearing loaded up into working memory. Let's say what we're seeing and hearing is a person telling a story about a birthday, their own birthday party, let's say last week. So we're witnessing this person tell a story about their birthday party. Now, as it happens, maybe we were at the birthday party. So you see, so the contents of working memory, which now are, listening to this person describe their own birthday party, the content of my working memory now is such that it might be triggering the activation of my own memories at that birthday party. Now, this is kind of a useful feature. So the memories that are retrieved tend to be related to what was just in working memory. This is a nice design feature. It prevents our thoughts from being simply random sequences of unrelated ideas. I mean, consider the alternative. Let's say the person was telling a story about their birthday party and I attended the birthday party, but somehow it triggered a totally unrelated memory, and I went on to then, share that, and it would seem sort of out of place. So the idea that what is in our working memory tends to activate related information stored in our long-term memory, that's a useful design feature. Relevant memories help us make better decisions about ongoing events. So it's really handy if we're currently perceiving some situation to have the working memory system retrieve related information about what's currently happening in my environment. That's a nice memory system. So now let's apply this to the educational world. And then we'll see what it means then, sort of to be educated versus less educated. So let's say somebody asks, what do you know about trees? So that'll be the cue, got loaded up into working memory from my auditory cortex. And so now I've got the concept of tree here in my working memory. So the idea is that the concept of tree is going to be searching my long-term memory systems for related information. Now let's say this person actually has a lot of information stored in their brain, and that's indicated by all these concepts written in green, and then these red connections. The dark red connections mean that these concepts are stored and interlinked. They are integrated into a network of knowledge, a web of knowledge. So if we say, hey, what do you know about trees? This person can reactivate the long-term memory associated with the concept photosynthesis. So you see, they can now, because they heard the word tree, they can activate the concept of photosynthesis in their long-term memory and then load that up into the working memory system and tell us that trees perform photosynthesis. In fact, they can go further. They know that photosynthesis involves the use of water and carbon dioxide, and it generates glucose, a sugar, with oxygen as a waste product. See, this person is well educated. They've got a lot of associated concepts that are interlinked. So when they hear the word tree in working memory, the working memory can trigger related concepts and retrieve that information, and that's pretty useful. Notice then a person with minimal education, they have a different kind of architecture down here in long-term memory. They might have a few concepts stored, but a lot of these concepts are weakly interconnected. In fact, maybe they've never even heard of carbon dioxide. Well, if they've never heard of carbon dioxide, they can't retrieve that information when asked about trees. So this person, they hear the word tree, and they might, be able to say a few things. Well, trees need water to grow, and maybe they release oxygen, but they didn't really understand well what photosynthesis was. So the less educated individual has fewer concepts, and the concepts are weakly linked. But again, it's the working memory system that has the access to the long-term memory system. That's the significance for our purposes right now. So what is it to get an education? So we want to be integrating new concepts into a web of knowledge, right? The well-educated person has strong links, allowing faster access to the information, more reliable retrieval, and slower rates of forgetting. But again, for our purposes, the new information, every time we're learning something new, it begins in working memory. So, successful students try to maximize the transfer of information from the working memory systems to the long-term memory systems. So this is a helpful way of thinking about study strategies. We have to understand a little bit about how our brains work. We've got these two memory systems. So if we want to be educated, we have to pay attention to how it is that the brain is taking the contents of working memory and writing them into the long-term memory system. How are we storing memories? And if we know a little bit about how the brain is storing long-term memories, then maybe we can design our study strategies more effectively.